Hey, welcome everybody to our next video here. This one will be a little bit more focused towards kind of updates on life. Some things I think got a little bit more serious. Honestly, just today for me, it's actually the 30th for me. I'm gonna be posting this tomorrow morning. So I kind of just want to give everybody an update, what's happening around, maybe calm some nerves a little bit, talk about what's more important in life than just math, but legally I'm still required to do you a little bit of teaching, so we'll finish it up with some stuff. So let me just make an agenda. This agenda is more just to keep my own sanity so I can tell you what I'm going to be doing. So the first thing I'm going to go over are the Arizona specific announcements and what they mean. Tour of the CDC websites with Mr. Richards' commentary. I'm going to talk a lot about what's going on with this disease here, and then the census info, just a couple of things about it. And then we're going to do a small school update, pretty important stuff actually in that school update, and then finally an actual algebra lesson. I just say algebra lesson because it's going to be the same. This portion of the video will be the same for both Algebra 1 and Algebra 2. All right, so let's get rid of this and go immediately to the Arizona specific, update that went on. So this right here, what I'm looking at on this screen is the executive order by Governor Doug Ducey. He made this official today. Couple things. The thing that you care most important about right now is this guy right here. A statewide school closure has been issued. It was extended to March 30th, but it actually is now until the end of the school year. So you are guaranteed not to go to school. Oh, you guys, can you not see my mouse on that screen? I don't know why that is occurring. You can see this getting highlighted, but you cannot see this getting highlighted. My girlfriend's looking at me like something is wrong. Something is wrong with my freaking computer.
You're stupid.
Okay. All right, well, I guess that's in the video. Anyways, I don't know why this is not highlighting, but the point is, I guess it's 1, 2, 3, 4 whereases down. It says on March 15th, school is closed till the 30th, and is now closed at the end of the school year. So you're not going back to school. Nobody is going back to school, in fact. Later on, there's a thing that talks about private schools that they really want to. They're allowed to resume after April 30th. But honestly, no one is going to be going back to school. Basically till August. Pretty much everyone is done with school, and we just have to do online schooling only. However, what this whole executive order, the other parts that are important for you, let's scroll down to it. Let's see, right here. Therefore, I, Doug Ducey, by virtue of the authority vested in me by the Constitution and laws of the state, including but not limited to blah, 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 effective 5 p.m. today, March 31st, 2020, Arizona shall institute stay home, stay healthy, stay connected policy that basically says that you can't leave the house. That's what this comes down to, is you are no longer allowed to leave except for very, very specific reasons to conduct essential activities. We'll read what essential activities are in a minute. For employment, that's none of you guys right now. In essential functions, maybe one or two of you, maybe you have a babysitting service that actually might still be part of it, but I think most of those are still closed. Utilizing the services by essential businesses, but you don't actually have to provide documentation or proof of this, but you don't want to upset any cops over this, though. So what are essential activities? Obtaining necessary supplies and services for your family. So you're still allowed to go to the grocery store, basically. You're still allowed to go to Home Depot if, your toilet has exploded and you need to take care of that. But for the most part, they don't want you leaving your house. You're allowed to get medical attention for health and safety, caring for somebody else, engaging in outdoor exercising activities, but only if appropriate physical distancing practices are used. So basically, if, you're not going out in a large group, it's literally 1 or 2 people, and you are only walking, hiking, running, biking. You're not looking at your phone. You're not trying to play Pokemon Go. None of that. Not allowed to happen right now, much to my sadness. But, that's how it is. You are still allowed to engage in constantly protected activities, speech and religion. However, most churches are also closed right now. basically don't go outside. You're not allowed to go do stuff. You cannot go hang out together. You cannot go have a kickback. Not allowed. You got to stay home. And the reason why is quite simple. I'm going to go ahead and exit out of this right here. And that is right here. Cases in the United States. I'm on the Centers for Disease Prevention and Control. You can't quite see the entire thing because of my face, but you know, over here now it's floating around over here, and you can see Centers for Disease Control and Prevention website. So what is important on this website here? Couple of things highlighted. It tells you how many total cases there are. This is our cases that are at 4 p.m. the day before. So this is actually out of date, 140,000. There's more than that now, but you know, this is like a day behind. And you can go through which, you know, the state right here, you can highlight Arizona. We got 919 as of yesterday at 4 p.m. I saw already that it's over 1,000 on another website, but it's a lot of people. You know, it's not nearly as bad as, you know, New York over here with 59,000 people infected, but you know, we're at over 1,000. So we have to take more serious measures to slow down the spread. And I don't know if you guys remember, but I talked about how there's going to be this exponential growth. That was on the 20th is when I made that video. So I made that video then on the 20th. So on the 20th, it was 18,000 cases, and we are now over here, you know, at 140,000. This pattern right here, where it grows like this is called an exponential growth pattern. We can't have that. If this exponential growth pattern continues, literally every single person in the United States is going to be infected with, you know, by the end of April, and it's not going to be a pretty thing, which is why they are introducing these new measures to make sure that people aren't going to be infecting each other as much. However, what I said before in that last video where I said you're pretty much going to get it, but you're going to be safe, still kind of plays into hand. And now that your odds of getting it in the near future go up, I wanted to go over on this website, the CDC's website, what happens, what are the symptoms, and what should you be doing. So let's click this guy right here, the symptoms of the coronavirus. There are three main ones: fever, cough, and shortness of breath. You pretty much always have these three things, all three of them, if you have the virus. You could easily have a fever without having the virus. Like my little sister was panicking. My mom was panicking about it because she had a fever. It turns out she had strep throat. Okay, so she was okay. Everything's fine. Just a regular old run-of-the-mill sick for a week thing, not this guy. So fever, cough, shortness of breath. Really what that means is it's really hard to breathe consistently. So you guys made jokes in my last couple of videos about me coughing. I actually still have a cough, but because I don't have fever or shortness of breath, it's highly unlikely that I have the COVID. It takes 2 to 14 days after exposure to be exposed to these things, which means that even though everything's so scary now, and now they're actually implementing all of the staying home rules, we're about 14 days behind about when everybody's going to start getting it. So when we were on the 20th and I said, okay, this is what things are starting, where you're supposed to be staying home. Well, that was the beginning of it. People were not following the overall warnings. People were still going out. You know, I saw, you know, all kinds of pictures all over the place, people doing things they weren't supposed to be doing, but it is what it is. 14 days later is when things can happen, though. So this is what you need to be looking out for. What should you do? What should you do if you are sick? Let's click this guy right here. I like this one. What to do if you are sick. Stay home, except to get medical care. What does it say? Most people with COVID-19 have a mild illness, are able to recover at home without medical care. Do not leave your home except to get medical care. Do not visit public areas. So really what this is, if you get this virus, most likely you're gonna be fine. It's going to be a little bit annoying for a couple of days. You're probably going to get a mild version of it. It's not going to be the end of the world. But you probably shouldn't even see a doctor unless you have emergency warning signs. What are these emergency warning signs? Let's click this guy here. What are the emergency warning signs? Real trouble breathing, pain in the chest, confusion or inability to arouse. Seriously, that's a thing. Blush lips or face. So you get continuously red in the face, or you have, you're being confused all the time. These aren't, all inclusive. I just read earlier today on another trusted website that you lose your ability to taste and smell at times. So that's another possibility that could happen. But this is when you seek medical attention, or only these 4 things for emergency. Otherwise, you're basically just chilling at home. You just need to be sick and do your best to not make it worse. If you need a couple days off of your homework assignments, hey, I got sick. I and every other teacher are going to be totally accepting of it, because going back to what I said in my first video, the reality is pretty much every single person in this country is eventually going to get it. We are just trying to do our best to make sure that doesn't all happen right away, because you can see what's happening right now in New York if you want to go look at the news over there. But what's going on is there's not enough room in the hospitals. They're making a makeshift hospital in the middle of Central Park right now, because they don't have enough hospital beds for people, because too many people are getting too emergency sick all at the same time. But if you spread that out, then there'll be enough hospital beds over the course of the entire year, as opposed to everybody in the next month. So that's the key. Basically, if you get sick, it's going to suck for a couple days, and then you're going to get over it. Life's going to go on. If somebody gets sick, the people you need to be worried about, back to saying what I said before, people over the age of 40. That's really what it comes down to, especially grandparents, older people with diabetes, severe overweight, anything like that. Those are the people who really need to make sure that they're going to be okay. So, anyways, I'm done talking about this coronavirus for now. Done talking about it for this moment in time. I want to go on to some more business that's actually super important for you that happens not today, but tomorrow for you guys, April 1st. It is not an April Fool's joke, but there is the 2020 census. So let's talk about what the word census means and kind of that really quick. I'm going to go to the census website. I forgot to bring this up. I should have brought this up right away. All right, the census. So you literally just go to 2020census.gov. I guess you guys can't see that right now because my head's blocking it. So let's see. This is the website right here, 2020census.gov. And 2020census.gov is going to be where you and your parents have to respond. You have to respond to this guy. It is quite literally a requirement. If you don't have a response, you're going to have a nice little federal agent show up to your house. A federal census agent is what they are called, and they will come and talk to you about it there. And you'd rather not have a person come to your house to do it. You'd rather just do it online. You can do it online, by phone, or by mail. What is the census? So hopefully everyone's had a survey in their life. I mean, you took a survey even for my class. A lot of people had a survey where I handed one out, or I did one on Google Forms, or whatever, where I made a survey. The census is just like a survey, except it's a survey of literally every single person in the entire United States. The word census itself means survey of everyone. So it is a survey of everyone in the United States. You can actually have a census of, like, the school, for instance. That'd be if I asked everyone in the school their opinion on something, then I would have a census of the school. But this is a census for the United States. So everybody in the United States who lives here has to answer this guy. It's important for your parents to respond. Anyone who lives here is required to respond, even if they are not documented. Even if they are only living here because they can't get back to their country of origin due to the coronavirus situation. Anyone who's here needs to answer this, the census here. Your answers are anonymous in the sense that the government is not going to contact you or use this information against you in any way, shape, or form. So this is a safe place to state truth about who you are, and it's pretty important that you help your parents respond to this. So if your parents struggle with technology or struggle with English, It's really, really important that you help them fill this guy out. They should have gotten something in the mail already that had their census code, and if they lost it, they can always contact over the phone to respond. So responding correctly also gets Arizona as a whole more votes. When we respond to things, it also gets just your town more votes for the entirety of Arizona. It's hard to fully explain right now, but every single person that's in a given area has their vote counted by representatives, and the number of representatives you have are determined by how many people are there. So having an accurate count is important, and if you aren't counted on the census, it's kind of like your future vote's going to matter less. So let's make sure that these are all accurate, that your parents do them, that you help your parents out if they need it. Yeah. All right. So we are almost done. I'm almost done talking. So we have one last thing that we need to take care of before the actual algebra lesson, and that is this guy, the final schedule. So if you aren't aware of this, I can't see what I'm telling you guys. And you know what? I need to get rid of my face for this so you can actually see this whole thing. So bye-bye face. Okay, I should have gotten rid of my face earlier on this one. Where's the transition button? There it is. Okay, bye face. All right, so let's read this here. This is for our school only. We're no longer talking about the whole United States, just us. Gateway is using Google Classrooms right now, but April 6th, we'll be moving high school classes onto Canvas. So this is our last week right here on Google Classroom. Teachers will post their assignments based on the schedule below. So I'm going to start following it this week. That's why I didn't post my video until now. But other teachers might not start following it until next week. If you have a class outside of your grade band that you're retaking and making up, please go to that grade band. If you failed biology 10th grade, blah, 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 it's just saying what to follow. Teachers have office hours online every day. I do have office hours every single day. I marked this up before. I guess they changed. Oh, this is a new check and connect. I'm out of the loop, man. I should be more in the loop on things. I apologize. This is different than what we looked at earlier today. All right, Gateway is giving out grades this semester. You must complete your assignments if you want to graduate or move on to the next grade level. That is really, really important. Some people don't seem to realize that if they do not do their Google Classroom assignments, if you don't just copy these notes that I'm writing down, I can't pass you. I'm required to show that you have done something. And for those of you who haven't been able to attach their pictures correctly, you really need to at least email me so I have some version of proof of saying, hey, this kid, they did some version of work. That's what I need right now. When we move to Canvas, it's a lot easier because I can give you quizzes and stuff. But right now, it's just that they do something. So let's look at the schedule together. For my class, this is what I care about. You can look at the other classes later for your other schedules. But here's me. Algebra 1 or 2 for 9th grade. Assignments are posted on Tuesday. And how it's going to work is teachers are going to post everything for the whole week on Tuesday. Then part of the homework, that is to say lesson 1, is going to be due on Thursday. Then the other part of the homework is going to be due on Sunday. The reason why it's due on Sunday is it gives me this Monday. All I'm going to be doing on that Monday is grading and maybe helping out people who couldn't get it done in time for one reason or another. So you're going to have all these days in between to do their work. So it's assigned on Tuesday, and you have Tuesday, Wednesday, and then Thursday, because I'm going to have it due at midnight. 11:59. So you kind of have 3 days to do the first lesson, and then 1, 2, 3 days to do the next lesson. And then in some ways, Monday is your day off of math unless you needed help completely. I mean, you're able to take Saturday and Sunday off if you got all your homework done by Friday. This is just a total spaced out way so you don't get overloaded with stuff on any given day. And if you notice, the only thing due on Wednesday is math. And the only thing due on Sunday is math. It seems that the day that you have the most stuff due will be Saturday, so maybe do that on Friday so you have less stuff to worry about, Mr. Ninth graders. But that is my own recommendation. So again, you have an entire week. I will be online. I don't know if my hours are going to be different than what they had me do before, but I was going to be doing 11 to 1 for my tutoring hours. Maybe I should just do noon to 1 according to this guy over here, but I don't know. Let's look at 11th grade really quick. So 11th grade, if you're in this, 11th grade also counts Algebra 2. What in the world? I'm so confused. I guess Algebra 2 is rolled into 11th grade here. Anyways, all math is the same anyways. It doesn't matter. I'll let you sit. I'll just sit this for a second here so you can see it. I believe this is getting emailed out to everybody anyway, so you can look at it on your own. But this is what we are doing. Anyways, I am finally done talking about school updates and everything else. Again, if you have any questions, comments, concerns, you're always allowed to email me. Contact me on WebEx. I'm going to get my beautiful face back up on here. I'm going to get rid of this, and we're going to switch over to the document camera. Let's get this going here. Let's do the actual homework we're supposed to be doing. Transition. Awesome. Okay, so I'm going to pause really quick. All right, so I have magically changed clothes because it's actually the next day. It's now March 31st here. I paused the video, ended up finishing Algebra 1 and finishing Algebra 2 right now. So our end behavior, polynomials, that's going to be our kind of our lesson for the day. It's technically still a part of, all this stuff we were doing. So I kind of want to review what this is all about, and we'll continue on. We've written a lot of stuff down for the last couple of days, and it has been 6 days since you thought about math, if you did your work exactly on time when you were supposed to do it before, so you can easily forget a lot of this stuff, especially with all the craziness going on here. So let's talk about our goal here. So we're talking about polynomials, which are things that kind of look like this guy, or this guy down here. They have these important features, the leading terms and degrees. We also wanted to know about end behavior, zeros, and multiplicities. So end behavior is today's lesson. Zeros and multiplicities, we talked about those a little bit before. So you could get a couple of these little definitions here. Polynomials look like this. We talked about it already. Our leading term, that's the biggest exponent there. It's the term with the biggest exponent. Root or zero, it's where it crosses these axes. Factor is related to those zeros. It's kind of what it factors into. Factored form looks like this, and as every single factor has these multiplicities, it's the exponents of our factors. We had a couple of examples up here. If you want to go over these again, we can. But what's more important for us today are end behavior. It's our very last idea. So let's write down our end behavior, what it is, what it means. So I'm copying directly from my paper that I made up before. Again, you can download that from Google Classroom if you wanted it. So end behavior is BH. Oh my gosh, I'm cut from the team. I need to get better colors here. And I should be doing a different color anyway. So we're going to use black for the word. I'm going to do end behavior. That is our vocab word. I'm going to write in purple for the actual definition here. And then end behavior is a description. So it's literally, you're going to be talking about something. Description of what is happening to the value, which is really the y, of a polynomial when x is very large in either the positive or negative direction. So we can get a good way of doing this, and because my handwriting is so terrible, I'm going to read it one more time. It says a description of what is happening to the value, which is a y value, of a polynomial when x is very large in either the positive or negative direction. Again, if you want a typed up version of this, I do have that available on Google Classroom. So let's go ahead and look at something really quick. So I have set up my Firefox to work out well. Let's see if it actually does for me. It did. I'm going to transition over here. Oh, nice. So what is end behavior? So let's look at something like super basic that we've already graphed before in the past. Let's look at y equals x squared. If you look at y equals x squared, when x is very large, when it's over here, what is happening to y? So 10 is not very large. Let's make it very, very large. Let's zoom out as much as we can here. Let's zoom, 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 zoom. As you can see, hopefully, no matter what the x value is, y just seems, it just goes up. It goes up and up and up and up and up, no matter how much I'm dragging here. Even when x is not that far over here, x is only like 500, it says here at the bottom. Y is getting nice and enormous. It's just kind of the way it is. I wonder if you can like easily reset the graph. Default zoom. Good. Hit home. All right. So the point is when x is big, then y is also getting big. Let's look at something a little bit different though. Let's look at maybe how about y equals. Let's do a little more complicated one. Y equals, how about negative x to the third plus 2x. There you go. That's not that complicated. But now what's happening as when x is getting big, when you're moving off to the right, y is going down. It's going down, 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 down. So you're asking yourself, what's happening way over here on the right when x is really big? When I say really big, there's not really a definition for what really big is. 10 doesn't work. 100 doesn't really work. It's really at the edges towards infinity. There's not a strict definition for where that is. But basically, it's very large. So we want to be able to say this in a nice way, not just say, oh yeah, y gets big. That's not really quite good enough. So we want to use the fancy notation. So the fancy notation will always be worded in almost exactly the same way. So it's going to be like this. It's going to say, I'm going to use blue. Actually, let's say green. I want to use blue. Let's use this blue right here. That's not really blue. It's more teal. Whatever. And I need to... Oh, you guys can't even see what I'm writing because Firefox is still in the way. Okay, goodbye. All right. So as x, we're going to say increases or decreases. So this word right there can be one of those two words. This guy is on the right. This guy is on the left. If it's increasing, it's on the x is big. Whereas, so this is big here, and this is like a big negative. So as x increases or decreases without bound. So that's how we're going to say it. To say x is really big, we're going to say instead, as x increases without bound. If x is really negative, like negative 18 million, we're going to say as x decreases without bound. So kind of what are these talking about? A bound is like a boundary, something you cannot go past. Someone could be bound if they're tied up. So without bound means you're not restricted at all. You can go, all the way, bigger, smaller, whatever it is. Okay. So as x increases without bound or decreases without bound, then f of x, which is the y value, will also either increase or decrease without bound. Please note, while this first statement up here, as x increases, decreases without bound, will always be what's happening for end behavior, because if you notice, end behavior is a description of what is happening when x is very large. So this first sentence will almost always be the same, or this first part before the comma will always be the same. But here, f of x increasing, decreasing without bound, only for polynomials. When it's different functions, which we will hopefully learn by the end of the semester, I don't know how much time we're going to have, they don't have to increase, decrease without bound. However, because this is a y value, this is f of x now. This is now not right. This is like up. and decrease is no longer left, now it's down. But it is still big or a big negative. That's way too much writing for a math problem. Way too much to say, way too much to do, so we shorthand it a whole bunch. So we might say, for instance, instead, as x arrow, that means approaches or goes towards infinity, f of x goes towards infinity. And again, what does that mean? This right here again means as x goes to infinity, or as x increases without bound, f of x decreases without, or increases without bound. If you put a negative in front of the infinities, then that would mean the decrease. So we looked at those two examples that I just had. I'm going to go back to them really quick so we can glance at them super fast. Let's open up this Firefox one more time. Let's transition back. So this guy right here, this was a negative x cubed graph, and a negative x cubed graph kind of ended up going down towards the end over here. And if I change this, just the x cubed, and I change just that cubed part, I change only that one, and I change that biggest exponent to a 4, all of a sudden, oh, it goes down on both sides. But if I change it to a 5, oh, it goes down to this. And if I change it to a 6, oh, it goes back down. What if I change it to a positive? Oh, positive, now it goes up. What if I change this to a 7? Oh, now one side goes down. So what's going to happen here is the only thing that actually matters for these problems are two things. The positive or negative of that first term, that leading term, and whether this is odd or even, that exponent. That's called the parity of the largest degree. So the word parity we're going to write down. That is another new definition for us. So the parity. Odd or even. So end behavior is determined by the parity. The parity of the leading term. So we're going to go ahead and make a cute little chart for this. So you could try to make it down at the bottom. Oh my gosh. I forgot to turn off my Firefox again. Alright. Sorry guys. Parity is odd or even. I messed up. Alright. Anyways. We're going to make a cute little chart. There's technically room down here, but I kind of want to make a new page, so I'm going to do it. Brand new page. And again, this chart is already on that Google Classroom if you want to check it. But this is going to be the end behavior chart. So for the end behavior, you're always going to be looking at the leading term. So this is determined by the leading term. As a reminder, that means the largest exponent and the leading coefficient's the guy in front. So to make this guy up, I'm going to go ahead and get a little ruler for myself. This is not actually an XY graph. This is just a sectioned off 4 sections here. So this is going to be for this little section up here is going to be for a positive leading coefficients. Coefficient and an even degree. So what does that mean? I'm going to switch to a pink for that. What that means is you have a positive x to an even power. As an example of a positive leading coefficient, even degree, x squared. The very first example I gave you was like that. Or if I had 6x to the 4th. So maybe I should write little examples over off to the side. I'll do that in, how about purple? Let's do some examples of these guys. So like 3x to the 4th, or 10x to the 6th, or I don't know, 1.5x squared. These are all guys, oh, you can't even see them. Whoops. So you got 3x squared, 10x to the 6th, 1.5x squared. These guys are all positive leading coefficients. So they have positive, 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 and you have an even degree. So the exponent is an even number. If that happens, the edges of the graph always, no matter what, create a happy face. From our definition that we wrote down just a bit ago, what's my last color I'm going to use? How about this blue? We would say as x approaches infinity, f of x approaches infinity. That is to say, on the right-hand side over here, on the right, y goes up. We also need to know what happens on the left-hand side, so let's write on the left-hand side. I'll do that in green. It's barely different even on that. All right, as x decreases without bound, that's the other way of saying it. So as x decreases without bound, the y value, well, as x decreases without bound, as it goes to the left, this still goes up. So y value still increases without bound. So we have now talked about what happens when you have a positive leading coefficient and an even degree, like this. You gotta make a chart for all four situations. So the next thing I'm gonna do is another positive leading coefficient. And this time we're gonna say odd degree. So what does that mean? It means that I have some positive number, x to an odd power. Yeah, so let's do some more examples of that. So how about, I don't know, this one might be a 2x to the third. So we have a positive guy in front here, and the exponent is an odd number. Or how about 10 x to the fifth? Or, I don't know, 7x to the seventh. That would, all those guys would be positive leading coefficients and an odd degree. If that happens, the graph ends up being opposite directions at the ends. So it kind of makes like an S at the ends. So let's go ahead and write down the next part. We gotta do our end behavior. Something is like in my eye. I don't know what the deal is here. All right, so we would say as x increases without bound, f of x, what's going to happen? Well, as x increases without bound and you go to the right, this guy goes up. So we would say increases without bound. As x approaches negative infinity, we could say instead, so I'm trying to use both the ways of talking about it, as it goes to the left, y goes down. So y goes down, that means f of x approaches negative infinity. Let's finish up this chart. We're almost done. We're halfway through the chart. Next guy up, negative leading coefficient. So we would have a negative leading coefficient. And for this negative leading coefficient, with an even degree, because you need both. So that is going to end up looking like a negative x to an even power. Well, on this guy, it turns out that you're going to end up creating a frowny face. Like a negative x squared. So that's actually an example, negative x squared. Or negative 5x to the fourth, or negative 7x to the sixth. All of these guys would be a negative leading coefficient with an even degree, an even exponent. Let's go ahead and write it up. For our last part, we would say as x goes towards infinity, f of x, well in this case, the y value goes down for both of them. So we're going to say it goes to negative infinity. Or, oh, I didn't do this one in green up here. I'm like so off, guys. Man, oh man. As x approaches negative infinity, or as x decreases without bound, f of x also decreases without bound, goes to negative infinity, because it goes down on both ends. So again, for x's, I'm just going to repeat this. For this guy over here, infinity is to the right, negative infinity is to the left. So this is saying on the right, y goes down. On the left, y goes down. That's all this is saying in kind of fancier notation and fancier words. All right, over here, our last one that we have to do is a negative leading coefficients and odd degree. I didn't write the D. What was up with that? Hey, so it'd be a negative x to an odd power. And what's that going to look like? It's going to look kind of like this S, but the other direction. And remember, this is only at the ends of the graph, it's not the whole graph. So we would say as x approaches infinity. So on the right-hand side, y goes down. So f of x approaches negative infinity. And we're supposed to switch to green now. As x goes to the left, y goes up. All right, we are finally done with our cute little chart. And now we need to do a couple of practice problems. So I think there's still room on that previous page for some practice problems, so I don't want to waste too much. So we can use our chart, definitely we'll use our chart, but let's go through our practice problems. We just have 5 of them, and we will be done with today's video. So let's start the practice problems here. So we want to, again, write the full English version of the word and then the math shorthand. You only have to write the full English once or twice as practice. Don't have to do the rest. So question's going to say describe end behavior. And behavior. And again, these questions are online on that packet, so if you're able to print it off yourself, you can. You just print it, you don't have to do it in your notebook. Describe end behavior. F of x, the first one, is going to equal 4x to the 6th minus 5x to the 7th minus 3. So these guys, again, are determined by the leading term. So you have to be able to identify the leading term. In this case, our leading term is the biggest exponent. So it's this guy. So our chart that we just finished writing up, here's our chart that we just did. We need to figure out what is the lead coefficient. Is it positive or negative? So is it a positive or a negative? And what's the degree? Is it even or odd? In this case, we have a negative x to an odd. So it's a negative leading coefficient with an odd parity. So we're going to be in this situation right here. Or we could write in English our end behavior as x increases without bound, f of x decreases without bound. So there's the English. I did English for one. I'm going to do math for the other. So the math for the other one might be as x decreases without bound, as x goes to negative infinity, then f of x, oh, I forgot the word as in front. As x goes to negative infinity, f of x approaches infinity. And again, how did I know it was this one? How did I know that as x goes to the left, y goes up? Well, this is our nice little chart. We have a negative leading coefficient, odd degree. So as x goes to negative infinity, f of x goes to infinity. If we wanted to double check that this is not just nonsense, it's actually good just to double check. So this is where my little Firefox guy is going to come back into play here. So let's do it. And I'm going to go back to main setting again. And I have to graph 4x to the 6th minus 5x to the 7th. And then minus 3. So it looks like this when I graph it. So I can see that on the right-hand side over here, x is on the right-hand side, that is, as x goes up, y goes down. And on the left-hand side, as x goes left, y goes up. So that's kind of where those answers are coming from. And I'm not going to forget to turn this off this time. Okay. We have a couple more practices. Now that you've seen one on your own, you might be able to do more on your own, and I would love to see you doing more of these on your own. So if you are able to do some of these examples by yourself, that would be great. I'm going to leave this chart by itself over here. We're going to go on to this. So here's our continued examples. If you want to label it, you can. Number 2. G of x equals, and I need 8 plus 100x cubed minus 1/2 x to the 4th. So again, your first job is to identify that leading coefficient, the largest exponent in the question, and that's this guy. So in this case, we have a negative leading term and an even exponent there. So because you have a negative x to the even, using that chart from that previous page one more time, we want to make sure that we have this guy ready to go. We're going to be flipping back to this a lot. So we have a negative leading coefficient with an even degree. That's this guy. So either way, we're going down. So sometimes what students like to do is they actually like to draw the little frowny face kind of right next to it just to remind them what's going on. Or the little S, so that way they can just quickly write up, as x goes to infinity, f of x goes to negative infinity, because on the right-hand side you're going down, and likewise on the left-hand side you are going down. So you go down on either side. Whew, okay, so 3. 3 is a little bit tougher, and the reason why is the leading term is not as obvious. So this is where that previous video comes into play of determining what is the leading term nice and quick. So the leading term in this problem is you ignore these little constants and you kind of apply the square. So the leading term in this problem is going to be 2 multiplied by 3x squared multiplied by x. Where in the world are these coming from? So this 2 comes there. That 3x is getting this squared, but you're not writing the minus 2. And then the x plus 4 is just getting that x. So you're writing each one of those separately, and then you got to multiply this out. So 3x squared is 9x squared like this, and finally you get 18x cubed. So 18x cubed is a positive odd, so again, you could draw that cutesy little s off to the side to remind you. That means as x goes to the right, y goes up. As x goes to the left, y goes down, which we will write as x increases without bound, f of x increases without bound. And why don't we write the full English just once or twice? I know it's annoying, but it's good to actually practice writing it all the way out. So as x decreases without bound, f of x decreases without bound. Ran out of room. And again, that just means as you go to the left, y goes down. All right, last 2. See if you can do these last 2 all on your own. I'll write the problem, then you should pause the video. So here's the whole question. This one's nice and short, actually. H of x equals x. All right, pause. Okay, hopefully you were actually trying the problem on your own and you didn't, skip ahead or something like that. Here we go. F of x equals x. There's only one term. It's that guy. So because it's, just that, we can draw our cute little s. Please note, this graph actually is not an s. It's actually just a perfectly straight line like this. But either way, it is still as x goes towards infinity, f of x goes towards infinity, and as x goes to negative infinity, f of x goes to negative infinity. One last problem to do, guys. One last problem. So I made it m of x equals negative x minus 4 cubed times x plus 2 squared. Here we go. Again, try to pause, see if you can do it on your own. Okay. So in this guy, our leading term that we need to figure out here, our leading term. So our leading term is going to be negative, and then we got x cubes x squared. So that's going to be negative x to the 5th overall. Don't forget you're adding your exponents when you're multiplying. And therefore we have a little negative s, like so. And that's going to mean as x increases without bound, f of x decreases without bound, or as x goes to the left, y goes up. And we're done, guys. That is the end of our video. Hopefully you survived through it. Have a great rest of your day. Hopefully I see you online on WebEx, tutoring just to hang out or something. See you later, guys. Have a good one.